In this video, we're going to do some work with stats. The majority of our work so far has focused on what we call measures of location. These were the mode, median and mean, and they gave us a central value. These were all called averages. We're now going to look at the spread of data, or the dispersion, and consider now standard deviation and variance. We've done a bit of work before with spread and looked at the range and interquartile range. The range was a very crude measure of dispersion or spread, as it took into account potentially what we would say were extreme values. When we look at the standard deviation, we're looking at the average distance of a data item from the mean. Variance is simply the square of the standard deviation. So it's the average square distance of each data item from the mean. What I want to do is look at an actual graphical representation of how we can find the standard deviation. So what I'm going to do is just draw up a little, I suppose it's some kind of physical representation of what we have. What we have then is what we call here x bar. X bar is the mean, or we might say mu. So let's say that this now is 5. What I'm going to do is put on some values right here. So here I'm going to have now 4 and 6. I'm going to have 4 and 6 again. I'm going to have 4 and 6. So what we can see here quite clearly, the average or the mean of these will be 5. 4 plus 4 plus 4 plus 6 plus 6 plus 6 divided by 6 will give us 5. We can see now that the average distance of each of these from the mean is 1. So this would have now a standard deviation, this data set of 1. If we consider another scenario, again with a mean of 5, and I'm just picking 5, could have been any value. What I could have now, for example, here is 3 more sets, and let's just put these on. So what we've got then is the following. We've got here, this would be, let's do 3, this now is 5, and this is 7. We've got now 3, we've got 7, we've got 3, and we've got 7. Again, we can see the mean of this data set is going to be 5. If I add all of these up now and divide by the number there are, we've got an average of 5. So let's have a look now at the standard deviation here, being 1. The standard deviation here is 2. The average distance from each of these data items to the mean is 2. So we can see the spread in this particular data set is greater than this one. What I'm now going to do is an example where we have observations, so observed values. So right here I'm going to have now my mean. This is mean, or x bar. Now consider I have the following. Let's go ahead and put some of these on. What we might have, for example, is 1 just here. Let's make that a dotted line. And then we can say we're going to have 1 just here, and then we're going to have 1 just here. So you can see that these are the same distance apart. If we have 1 just here, and we have 1 just here, again, these are going to be the same distance apart. It doesn't really matter, I'm just giving examples of this. So what we'd have is the following. So let's say we now have, let's say this is x1, let's say this is x2, let's say this is x3, let's say now this is x4, let's say this is x5 and x6. What we're going to do now is consider subtracting x bar from each of these. So if I did now x1 minus x bar, that's going to give me now a negative number. If I consider now x2 minus x bar, that 2 will give me now a negative number. If we have now x3 minus x bar, that 2 will give me a negative number. If I come this side and say x4 minus x bar, that will give me now a positive number. So I've got a positive. I've got now x5 minus x bar, that will give me now a positive number. And then finally x6 minus x bar, 2 will give me a positive number. Now, if I sum all of these up, and let's say now that this is the sum, let's write this here, the sum now of xn minus x bar, this is going to be 0. Now, you can see that this is going to cause problems, because if I try and sum these now, as I did here, I can see that this is going to be 1. We can see all of these are going to be 1. And when I divide them now by 6, we're going to end up with 1. In this scenario, what's happening here is we're actually going to end up with 0. So to get around this, what we do is consider the square distance. And what we can say is the variance, and I'll write this here, the variance, or we might say sigma squared, will be equal now to the sum of now, we'll have xn minus x bar squared over n. So what we're doing is making essentially all of these now positive. And that's what we've done here. If we consider what this one is, this is going to be minus 1. This is going to be minus 1. This is going to be minus 1. This is going to be 1. This is going to be 1. This is going to be 1. When we square each of these now, we're going to end up with positive 1. So to get over the problem now of this negativity, or the negative value, we simply go ahead and square it. The variance is simply now the average squared distance from the mean. The standard deviation, or sigma, is going to be equal now to the square root of this summation. So the summation now, or the average I should say, xn minus x bar all squared over n. Now the difference right here, this is the average squared distance, and this now is the average distance. If we were working, for example, in centimetres, this would give me an answer in centimetres squared. The standard deviation, or sigma here, would give me in the original answer, or the original units. So if we're working in centimetres, this would give me an answer in centimetres squared, this would give me in centimetres. And that's what we're looking to do. We're looking to get it back in the original units rather than a squared term. Working with this particular formula can get a bit of a nightmare as we go. So what we're going to look at now is finding an easier way to calculate both the variance and now the standard deviation. And we can say sigma squared, or the variance, is now the sum of x squared over n minus now the sum of x over n all squared. So this now gives us variance. The square root of this is standard deviation. This now is the mean of the squares minus the square of the mean. So if you want to remember this, that now the mean of the squares minus the square of the mean. So this now is variance, and we can go ahead and calculate all number of problems using this particular formula. So let's go ahead and look at a few examples of this. Say we were given 10 items, so 10 items. And we were told now that the sum, and we might be given something along the lines of the sum of x squared is equal to 24, and we were told the sum of x was equal to 8. These are called summary statistics. So you might be given a question and you might be asked to find 1, the variance, and now 2, the standard deviation. You might even be asked to find now the mean. So if we consider the variance, we can write now variance is given to be now the sum of x squared, so we can say the sum of x squared over n minus the sum of x over n squared. So let's sub these in. So we're going to have 24 divided by 10 minus now the mean. The mean is going to be 8 over 10, which we need to square. So what we can say in this particular case, we can say x bar, or you might see this being written as mu, is going to be 0.8. So this is going to be 2.4 minus 8 tenths squared, which is going to give me 0.064. So what's that? 0.64. So what's that going to give me? That's going to give me now sigma squared, or the variance is this right here. So the sigma squared, the variance, is going to be 1.76. So if I wanted the standard deviation, it's now the positive square root of this value, and we can just simply put this through a calculator. So positive root of 1.76, and we can say now that that is going to be 1.33, and that's now to 3 significant figures. So we can say now sigma is 1.33, and that is to 3 significant figures. So what does it tell us? It tells me that the average distance from any data observation in this particular set of numbers is going to be 1.33 from the mean. So we were given here summary statistics. The average squared distance is 1.76. Let's look at another example. Let's take some people. Let's take some people's ages. Let's say we've got now some ages. Let's go for 10, 8, 21. Let's go for 12. Let's go for 14, 15, and we'll have 17 and 9. Now, often it's easier, and especially if we're working with group data or frequency tables, to actually put this up. You certainly don't have to, but often just putting this into a table is going to help. So what we're going to have then is X. We will have 10. We will have 8, we'll have 21, we'll have 12, we'll have 14, we'll have 15, we'll have 17, and we'll have 9. I then like to have a column x squared, and we'll have 164, what's 21 squared? 441, 441, 144, 196, 15 squared is 225, 225, 17 squared is 289, and then 81. So what we can say then, these are people's ages. So they're the ages now of a group of people. So if we consider now, what we can say is the variance, or sigma squared, is going to be equal now to the sum of x squared over now n minus the sum of x over n squared. So how many people have we got here? We've got in total, that looks to be, what is that, 8 people? So we've got 8 people. So what we want then is the sum right here. So what I'm going to do first is just go ahead now and look at this sum right here. So along the top now, I'm going to get up the values. Now you can be quite lazy if you want. You can do 10 plus 8 plus 21 plus 12 plus 14 plus 15 plus 17 plus 9, and that gives us 106. So what we can say, just putting it here, the sum is equal to 106. So straight off now, the mean, we could do 106 now over the 8. What I like to do at this stage is be a bit lazy, and you certainly don't have to do this on a calculator, though you can just go in and just change these to the square terms rather than typing out all again. Just be careful, I often slip on this, but it just often makes your life slightly easier just to plug these in as now the square terms. So let's go ahead and do that. And that now gives me 1540. So we can say the sum now, so let's do the sum of x, and the sum of x squared is 1540. So what we can now write is the variance, or sigma squared, will be equal now to 1540 over n, or n is 8, minus now 106 over 8, and we're going to square that term. So let's just get 106, so 106 divided by 8, what's that give me? 53.4, so 13.25. So we can see 13.25 is the average age of these people. So what we can now do is the following. We got sigma squared is now, don't need to do this bit, but I'll just put this 1540 over 8 minus now the mean squared, which is 13.25 squared. You can just plug that in. I was just interested in finding that value, because often you'll be asked it. So if we square that, and then all we'll do now is for 1540, so 1540 over 8 minus my answer. And this will give us now the average squared distance from the mean. So minus my answer, 271 over 16, which is going to give me, what, 16.9375. That is the variance. So if I now square root that, this now is the standard deviation. So let's say 4.12. So we can say now sigma is equal to 4.1. What's it? 4.12 to 3 significant figures, and that looks pretty good. So what this is saying now is the average distance away from the mean age of these people is 4.12 years. So that now is looking at some basic data sets and finding both the variance and the standard deviation. We can extend this to group data or data from a frequency table, and we can give now sigma squared the variance. So let's write the variance. The variance is going to be given to be now the sum of f of x squared over now the sum of f minus, then we'll have the sum of f x over now the sum of f squared. Now if this is group data, what we would do is take x to be the midpoint. So let's make up some group data. Let's go ahead and do this with group data, and then we'll just do it from the frequency table as well. So what I'm going to have then, let's put some values in. Let's just go ahead and do this. Let's do that, and we'll just put up a few columns. Let's put one more. So what I'm going to have then, let's say we've got some scores. Let's say now this was a test. Let's say a test. And scores were 0 to, let's go 0 to 30. So what I could say now is the following. So let's say I got 0, and then I got S, and then I got 10. So let's do 10. We've got 10, and then we've got S, and we've got 20. Then I've got 20, then we've got S, and we've got 30. So what we're going to have then is a frequency, and let's make these up. Let's say we've got, let's go for 12, 16, and let's go for 8. Now, let's look at the midpoint. The midpoint in this particular case now is going to be our x. So what we've got then is the midpoint. The midpoint is going to be x, and in this one we're going to have 5, we're going to have 15, and we're going to have 25. So if we consider now just here, this is x, and then if we think about now x squared. So if this is x, x squared will be 25. Then we'll have now x squared, which will be 225, and then we'll have 625. So in the next column, what I'm going to have is fx, and then we'll have fx squared. So if we consider fx, well, f times x, 5 times 12 is 60. Then we're going to have 15 times by 16, which is 240, and then 8 times 25, which is 200. Okay, on this one, what are we going to get? 125, what's that going to give me now? Sorry, we're doing this one, aren't we? 12 times by 25. So f times x squared, 12 times 25 is 300. 16 times 225, let's whack that for a calculator. 16 times 225, what's that? 3,600, let's put that in there. So 3,600, and then finally now, what have we got? 8 times 625, a bit lazy, let's put that in. What's that going to be? That's going to be 5,000, isn't it? Let's just check that. 8 times 625, 8 times 625, 5,000. Okay, so let's look now at the sum of each of these. So the sum now of fx squared is going to be these added up, which gives me what? 8,900. Okay, if we look now at the sum of fx, what's the sum of fx going to be? That's going to be in here, or that works out quite nice, that's going to be 500. If we now consider the sum of f, let's look at the sum of f, what do we end up with? 36. Okay, so let's go ahead and do this. So let's do the variance. So what we've got then is the following. We've got the sum of now f of x squared. So that's going to be 8,900. So 8,900 over the sum of now, let's just put that as sum of f. The sum of f is going to be 36. Minus now this one right here, which is going to be 500 over 36, and we're going to square that. So let's go ahead and work this out. So let's see that. So what we're going to have then is 8900 over 36 minus now, what's that going to give us? Let's go for that one. 500 over, and let's just check I've got all this plugged in. 500 over 36, that looks pretty good, and we'll square that. So what's that give me? That gives me 54 point, let's say 54.3. So the variance now, so variance is going to be now 54 point, and we'll say 54.3, and that is now to 3SF. Now we want sigma, which is standard deviation, which is a square root, positive square root of this. So let's go ahead and root this. And that gives us now 20 root 11 over 9, which is 7.37. So 7.37. So that now, again, 3 significant figures. So that now is telling me that the average score was 7.37 marks from the mean. So that's the standard deviation sorted. So that's an example now from group data. We could, of course, just use a frequency table. If we did a frequency table, let's go for some values on a frequency table. Let's say we had these values. Let's say now, again, these were scores. So say you could score anywhere between 10 and 13 on a scale. let's say we did that, and we could put these in a table. So what we'd have is the following. Let's build up a table, and exactly the same as before. It's just this time we've not got a midpoint, so we would simply call x the value of now 10, 11, 12 or 13. So let's go ahead and do this. So what we'd have then is the following. Let's say we've got now, let's say x is going to be here. We've got 10, we've got 11, we've got 12, and then we've got 13. Let's say we've got a frequency. Let's go for the frequency on each of these. Let's go for 2. Let's put 2. Let's make this nice and straightforward. 2, 5, 3, and 4. Now we can see quite clearly we've got x. Let's now put in x squared. So that's going to be 100. That's going to be 121. That's going to be 144. That's going to be 169. So if we consider now let's just say f of x in this one. Let's consider f of x. Well, f of x, we're going to end up with 20. Let's put 20. 55, we're going to end up now with 36. And we're going to end up now, what's that going to be? 52. Okay, and then finally, if we look now at f multiplied by x squared, remember x just here, x is just given to be the value. This is just from now a table, so a frequency table. Let's go ahead now and do this. So what are we going to get on this one? We're going to get now, what's that going to give me? Frequency times by x squared, that'll give me 200. What's that one going to give me? 605. What's this one going to give me? 4. Let's have a look at that one. Let's whack that through the calculator. What's that going to give me? 400. What are we doing? Fx squared. Let's get my brain up. 3 times 144. Should know better. 3 times 144. What's that give me? 432. So 432. So that's 432. And then this one right here, what's that going to be? 676. Let's just check that. So 4 times by my brain's going a bit off. 676. Right, okay. So let's now sum these up. So we can say the sum of f now is going to be equal. What's that give me? That gives me a total of 14. Okay. Now if we look at this one, what have I got? 20, 36, 52, and 55. What's that? 163. Again, let's just add this up. Let's add these up. Let's just do now the f of x first. So let's do that. 20 plus now 55 plus the 36 plus the 52, and that gives me 163. So we can say now the sum of fx is the 163, and then we'll do the final one. So what we're going to get the sum of fx squared. So 200 plus 605 plus 432 plus now 676. Hopefully all my calculations are good on this. So what's that give us? 1913. So the sum now of fx squared is equal to 1913. Okay, so let's go ahead now and just consider what we've got here. We can say the variance. So variance will be equal now to, we know that this is going to be the sum of fx squared over the sum of f minus now the sum of fx over the sum of f, and that will be squared. So the variance of this one is going to be 1913 over now the 14, so we'll put that in, minus now the 163 over 14, which we need to square. Hopefully all these values are right. I'm kind of being a little not as attentive on this particular one. Hopefully you're getting the understanding of what's going on there. Minus now the value, so let's do that, 163. So 163 over 14, which we're going to square. Okay, so this now will give me the variance, or the average squared distance of each data item from the mean, and that gives me what's that going to be? 1.086, and so on and so forth. So let's just check I've got all of that in there correct. 1913 over 14, and then we're going to have now minus for 163 over 14 squared. So that now gives me 108. So let's write that there. The variance is going to be now equal now to 1.09. We'll say that is to 3 significant figures, and then we'll take the square root of this. Let's go ahead and square root that, and that will give me 1.04. So SD is equal to 1.04. So let's just check I've got those in right. Let's do that. Let's check that I've done them right. 1913 over 14. And then if we subtract away from that now the quantity 163, 163 over 14, and we square that. Let's go ahead and do that, and that will give us now our 1.08, so 67, and so on and so forth. So there we go. That now is working with the standard deviation and variance. So all we're looking to do is find the average distance of each data item from the mean. So we've looked at it now both with grouped or data tables and then just single values.